Hello student, this video will show you how to compute the probability of a binomial event. So we're going to look at the example 1 on page 64 of your course package. So this is an experiment which consists of tossing 6 coins in the air and determining the probability that 4 of the coins, exactly 4 of the coins, will show heads. So let's go into our whiteboard here. So we know we're looking for, we have 6 coins. We want to know the probability of tossing those 6 coins and having 4 of them, exactly 4 of them, show heads. It's because we're talking about probabilities. The probability of success, heads, in this example, for one coin toss is 0.5. So the probability, binomial probability, that x equals 4, so basically would be written as this. The first part, NCX, so we have 6C4. Then I'm going to change colors here. We're going to go with this orange color. We have P, which is 0.5, to the probability x. Changing colors again. And then we have 1 minus 0.5. in brackets, the power, in brackets, 6 minus 4, n minus x. So I really think the best way to do a binomial is looking at it in 3 specific parts, understanding that we're going to be multiplying those 3 values. So when we go 6C4, this is a combination. You calculate, you're going to have that NCR button. In binomials, we just change that R to an X, so it's going to be NCX. But as I said, it's the NCR function. You calculate it. You run that through, we're going to get 15. Change it to that color. 0.5 to the power 4 is 0.0625. 1 minus 0.5 to the power 6 minus 4. Now just a little caution here when you're doing this in your calculator that you're entering brackets as needed, because some calculators may not give you the same correct answer. So 1 minus 0.5, which would be 0.5 to the power 6 minus 4, or 0.5 to the power 2, would give you 0.25. Keeping in mind that we are going to be multiplying those 3 things out. So our final answer, when we multiply 15 times 0.0625 times 0.25, is 0.2344. And that's rounded a little bit. 4 decimal places is really good. So that's our answer to the first question. Before we move on to the second question, a couple things to understand here. When we have 6 coins, and we can see we have 6 coins right there, n equals 6, x can basically range from, x could be anywhere from 0, 1, 2, all the way up to n, in this case 6. So we cannot have 6 coins and look for the probability that 7 of them show heads, or a fraction of them show heads. Binomials deal with discrete numbers, whole numbers, and we just have to keep in mind that x can range from any value. So when we actually do, if we did this calculation for every x value, we would find, I think I've done that in this Excel file here. Let's make this a little bigger so we can all see it. Using Excel to help us find these calculations, we have n equals 6. There's our 6 coins. Probability of success on one coin toss is 0.5. And we would have x ranging from 0 all the way down to 6 with associated probabilities. This is the probability that we've calculated when we were looking for the probability of exactly 4 heads. These 7 probabilities from 0 to 6 are going to add up. Let's just write that in there. Our total has to be 1. we've accounted for all the outcomes. There's no other outcome possible, so of course the probabilities have to add up for 1 for trials or events that include all possible outcomes. We'll get to this mean, variance, and standard deviation later as well. But just keep this in mind because it'll help answer some of these other questions. Let's put that over there. Come on, move. Make that a little smaller. Let's go to our Word document. We want to know the expected number of coins that will show heads, and then in part C, the standard deviation of the number of coins that will show heads. Let's go back here. Let's delete this page. So we want to know the expected number. So I believe the question asks for this, the expected number of coins that will show heads. That's another way of saying or calculating the mean. The mean of a binomial is equal to n times p. In this case, we have 6 coins. The probability of success on one coin toss is p. In this case, it's 0.5. So we would expect 3 of the coins to show heads. Variance is that symbol. Variance is n times p times 1 minus p. So substituting in the value, 6 times 0.5 times 1 minus 0.5 will give us a variance of 1.5. Standard deviation is simply the square root of the variance. The square root of 1.5 would be about 1.225. So remember those 3 formulas. The mean is right there, n times p. The variance, n times p times 1 minus p. And then the standard deviation is basically the square root of n times p times 1 minus p. So let's delete that page and go on to this question here, part D. The probability that at least one of the coins will show heads. This is a great question for binomials because of the keyword right in here, at least one. So how would we write at least one? At least one would be written as this. What is the probability that at least one of the coins? So this is basically saying that at least one. So what could x represent in this situation? X could basically be 1, 2, 3, all the way up to n. In this case, n is 6. So to do this calculation, we have to look at, let's just erase this a little bit. We have to look at doing 6 calculations. So we would find probabilities for x equals 1, add that up with the probability of x equals 2, and do that calculation all the way up to x equals 6. We're going to have 6 probabilities, we add them up, and that's a probability that it is at least 1. If we go back to the Excel file, we have the probability when x equals 4, right there. We'd have to do the probabilities for these events when x is 1, 2, 3, 4, 5, and 6, and add those up. That's a series, in this case, of 6 calculations. If n were 10 or 20, that would be, a headache to do on paper. So another way of doing this is understanding that the probability of at least 1, so the probability that x is equal to or greater than 1 is everything except for what we don't want, the probability of 0. If you look at this Excel file again, we want these probabilities. We want to know the total of those 6 probabilities, which is everything, almost everything. So it's everything minus this. Making sure, as we remember that if we added up all these probabilities, they add up to 1. So if we knock off this probability, we would be left with a summation of the remaining 6 probabilities. So this one's a little easier to do because all we need is one probability. Let's just erase this. So it's going to be the probability of when x equals 0. So that's going to be 6c0 times the probability 0.5 to the power x, 0 times the probability of 1 minus 0.5 to the power n minus x, which would be 6 minus 0. And that's all in brackets there. So keeping in mind that when we're doing this, we're multiplying those three things. So we have those three parts of this binomial distribution. So we have 1 minus 6c0 is 1. 0.5 to the power 0 is also 1. Anything to the power 0 equals 1. 0.5 or 1 minus 0.5 to the power 6, this would be 0.0156. And that is in brackets. So it's 1 minus everything in brackets, so it's going to be 1 minus 0.0156, which would equal 0.983 or 9844. Let's just make that a little neater. Can't be showing a messy video. .9844. So when we go back to that Excel file, if make this larger here, oops, these 6 probabilities added up. Oh, let's just do that over here. We can go equals sum, adding up these 6 probabilities is 0.9844. If we go doing the shortcut way, 1 minus, or everything except for 0, 1 minus that probability when x equals 0, we get 0.9844. The same way. In Excel, any way is easier. On paper, definitely, when the question is at least 1, you solve for 0, as we did here, solve for 0 and subtract it from 1.